I am Anil Kumar sharing with you another excellent question from my subscriber. Let me thank all the subscribers and viewers for participating actively and posting such brilliant questions. You have indeed made my channel wonderful. This question relates to calculus optimization. The question is, a sports association is planning to construct a running track in the shape of a rectangle surmounted by a semicircle as shown in the figure. Find r in terms of x, that's part A, and determine the value of x such that that maximizes the area enclosed by the track with perimeter of 600 meters. So this radius is r, that means the width over here will be 2r. This side is x, will be equal to x on this side also. So perimeter, let's say P, which is sum of all these sides, can be written as equal to 2x plus 2r plus half of the circumference, half times 2 pi r. Right? Perimeter is given to us as 600 meters. We can write this as 600 is equals to 2x plus 2r. Now we can take r common. This can cancel 2 and 2. Since we need to isolate r, so we'll take r common. So we can write 2 plus pi here, and we are taking r common. So let's isolate r now. So we have 600 minus 2x equals to r times 2 plus pi, or we can write 600 minus 2x divided by 2 plus pi as equal to r. Right? So that becomes an expression for r. This can help us to write area function in one variable. So what is area? Area in this case is area of the rectangle, which is 2 times r times x, 2rx, plus half the circle by r square. Right? That is the area. Now in this, we can substitute the value of r to get the function of area in terms of x. That's the whole idea, right? So if I write r value here, I get 2x times 600 minus 2x over 2 plus pi, plus here we get half pi and the square of all this, which is 600 minus 2x over 2 plus pi whole square, right? So that becomes the area expression, which we can simplify a bit and then work with. Now let us take this to the next page, and then from there we'll actually find the derivative, equate it to 0, and then work it out. So we'll move it to the next page to find critical number, right? So we'll do critical number in the next page. Okay, so let me rearrange and copy this equation first, and then we'll find the derivative. The area function a of x can be written as, so we'll take 2, I'm just rearranging 2 over 2 plus pi, these are constants, and we'll multiply x with 600, we get 600x minus 2x squared, that's the first term, plus the second term, we'll write this as pi over 2 times 2 plus pi whole square, and within the bracket we get 600 minus 2x whole square. So what I did was that we have this expression here. So I took 2 over 2 plus pi, this is a constant. Here we squared 2 plus pi whole square, brought it here, right? So what we get is this expression, correct? Now we can find the derivative with respect to x. So we get dA dx as equal to, the first term is constant, which is 2 over 2 plus pi. The derivative of this term is 600 minus 4x. Here we get plus pi over 2 times 2 plus pi whole square. And the derivative of this function is twice 600 minus 2x times derivative of inside function, which is minus 2. Right? So that becomes the derivative. Now, for critical number, dA dx should be 0, right? So, for critical number, this is equal to 0. So, we'll write this as 0 for critical number, since we need to maximize the area, right? And what we can also do here is, we can take this common factor. So this factor, 2 over 2 pi, so this 2 and this 2 actually cancels, and that negative sign will bring here, but we could take one of these out, correct? So if you do that, you get 0 equals to 600 minus 4x. That's the first term here. And on this side, we get minus because of that 2, minus. And we cancel these 2's, so we are left with pi here. So minus pi times 600 minus 2x divided by 2 plus pi. Is that clear? So we cancelled 2 and 2 and 2 plus pi in the denominator, but we are left with 1, right? Now, we'll multiply everything by 2 plus pi to just get a linear equation. So we get 0 equals to 600 minus 4x by 2 plus pi. And we have this term here, let's open this up, minus 600 pi plus 2 pi x. Let's open this also, simplify. 600 times 2 is 1200. 600 pi plus 600 pi minus 8x and minus 4 pi x. We have minus 600 pi and plus 2 pi x. So 600 pi and 600 pi cancels. So we can write this as 0 equals to 1200. Here we have minus 8x, minus 8x. So we could take x, let me write minus 8x first. And minus 4 pi x and plus 2 pi x gives us minus 2 pi x. Now we can take x common, right? Bring them to the right side. So on the right side, we get 8x plus 2 pi x equals to 1200. Taking 2x common, we get 8 divided by 2 is 4, and here we get pi plus pi equals to 1200. And that gives you the value of x. So x is equals to 1200 divided by 2 times 4 plus pi, which is 600 divided by 4 plus pi. So that becomes the value for x. Correct? So that is how you can actually simplify this particular expression and get the value of x. Now, to prove that this is indeed a maximum, what we can do is that we can take a test point on either side and then figure it out, right? So, if this is a critical number, you need to analyze the first derivative. So the x value is this. We have dA dx expression, which is kind of simplified in this form here because taking this. So that is the simplified form. So in this simplified form, we can substitute a value which is more than this and which is less than this to find the answer, right? So that is what can be done. You'll find that if you substitute a value less than x, it will be positive, and if you substitute a value more than, then be negative, and that will result in a maximum. So that is the only critical number, so we are leaving it here, and I am leaving this as a test for you. Okay, so we get our answers. The two answers which we have got are that R value is equal to, let's get back to our notes, R is equals to 600 minus 2x over 2 plus pi, and x is equals to 600 over 4 plus pi. So that is the answer. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. Thank you once again for posting this excellent question. All the best.